Before we get into our next example here, we are eventually going to learn how to graph logarithmic functions. But again, before that, I wanted to point out this page in your textbook. It's page 454. Hopefully you can see my cursor moving around here. So we're on page 454 in your textbook. And talks on this page, just to kind of reinforce the idea that logarithms and exponential functions are inverses of each other. So in the red line here, this red line shows the exponential function y equals 10 to the x power. And we've already learned how to graph exponential functions. So we use those values for x, -2, -1, 0, 1, and 2. And you can see some of our points that are on here. So 0, 1, and 1, 10 are points. Okay? Now keep in mind one of our big ideas with inverses, x and y switch. So this point 0, 1 switches to become 1, 0, and that point is on our blue function, which is the equation y equals the log of x, and the base here is really 10. That common log, remember that if the base isn't written, it's really a 10. So then this other point on our exponential function, 1, 10, flip the x and the y value around, we get 10, 1. Okay, so that's one of the main ideas when we are going to graph our logarithms, that if we think about what the exponential form would be, we can switch x and y values around there too. So let's look at our first example here. Example 4a, we are graphing a log function. We are going to graph y equals the log base 2 of x. And then after we graph, we're going to describe the domain and range, the y-intercept, and identify the asymptote. Before we start figuring out how to graph this logarithm, think about what the log means. I'm going to rewrite down here, y equals the log base 2 of x. It really means 2. That's the base of our log, so we start with the base of our log, the base of our exponent. 2 to the y power equals x. Okay, so now this looks really, really similar to the exponential functions that we've graphed already. So let's start off with the same idea here. We make a table of x and y values. And before, when we were graphing something like 2 to the x power equals y, we chose those values -2, -1, 0, 1, and 2 for the x column. When we're graphing our log function, or 2 to the y power equals x, we want to use those same values, but for our y instead. -2, -1, 0, 1, and 2 for y. Because if we use those values for y, I have 2 to the y power. I can take 2 to the -2nd power. It's a little harder to think about what x values I would choose. Okay, so easier to choose y values. 2 to the -2nd power is 1 over 2 squared, which is 1/4. 2 to the -1st power is 1/2. 2 to the 0 power is 1. 2 to the 1st power, 2 to the 2nd power. And now I can plot these points. So it seems kind of weird because we're choosing y values for our table instead of the x values. We're starting with our y and then finding x. It's a little backwards than what we've done, but also hopefully kind of makes sense when you remember that logs and exponentials are inverses. The x and the y switch. So let's plot these points. We have 1/4, 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. Connect our dots. And this is what our graph looks like. Jumping back to that textbook page for a second. If we look at how these two are related, remember that exponential functions have asymptotes, those horizontal lines that our graph isn't going to cross. Log functions still have asymptotes in the same way, but our asymptote is vertical. We have a vertical line that our graph won't cross. Okay. So that's important when we're figuring out the other pieces here, our domain, our range, our y-intercept, and the asymptote. So our domain, again, keep in mind that we have this asymptote here. Our graph's never going to go on this left side. So our domain x has to be greater than 0. Okay, and x can never equal 0 either. Okay, because 2 to any power, if y is positive, we're going to get big values. If y is negative, we're going to get small fractions. We're never going to be able to get 0. Our range, well, if you look at the graph, this line keeps going down forever, and this part's going to keep going up forever. So our range is all real numbers. Our y-intercept, since we're never actually going to have an x value of 0, we don't have a y-intercept. And then the asymptote, that's our vertical line here. Probably can't see too well over the blank on the grid. But we have a vertical line, and remember that vertical lines are in the equation x equals something. So vertical line on your y-axis going through the origin, our equation is x equals 0. Okay? So hopefully you're seeing some similarities between our exponential functions and our logs, the fact that we switch the x and the y value around. We still have asymptotes. We still have kind of limits on our x values that go in here instead of our y values.